Here you go. Naveen, can you see my screen?
Yeah.
All right, just give me a second. All right.
Okay, perfect. Okay, yeah, so welcome guys today to our second official class. Yeah, we're really excited to have you guys here again. Thank you guys so much for coming. Hopefully, like most of you guys were here last week, and last week we talked about linear regression. And yeah, let's just jump into today. We have a pretty busy schedule. Um, So just to break it down, today's class, we're going to be covering logistic regression, like what it is and how it works. And then our coding exercise for today is also obviously based on logistic regression. If a lot of you guys are like interested in the medical field, today we're actually going to be teaching you guys how to make your very own like diabetes detector. And then we're just going to run through some quick announcements. And then lastly, like the part I'm personally most excited for is we have a special guest interview today at the end, which is going to be really exciting. So hopefully you guys are looking forward to that. Yeah, and then just to jump into it, because we have to go a little bit quickly, but let's just get started with logistic regression theory. So last class, if you guys remember, what like the big question we had was, can we predict the future from past data? So last class we talked about linear regression. Linear regression finds the line of best fit in data and outputs a numerical prediction. For example, we could be predicting a student's exam score based on how many hours they study. So the exam score is going to be from like a range of like 0 to 100. That's a numerical value that it's going to output. But what if we wanted to make different types of predictions? For example, we could be looking at, will a customer buy a product? Is an email spam? Does this patient have a specific disease? Will this student pass the test? So all of these predictions, they all have in common that they're not necessarily numerical, but binary, meaning they have two outcomes, either yes or no. Either when it comes to binary, it means like one or zero, positive or negative, true or false. Like looking at each of these questions, then output is not going to be a numerical value. It's going to be like an answer to the question. Like for example, is an email spam? We're going to have the output, it's going to be a category, either it's spam or it's not spam. That's not necessarily a numerical output. This is what logistic regression is helping us with. So what is logistic regression? Logistic regression is a statistical model used to predict binary outcomes, just like I was saying, yes or no, one or zero. For example, like, will a customer buy a product? Will a patient have diabetes? It outputs probabilities that are converted to classes. So basically, like what it's doing is essentially it's like instead of like outputting a number like linear regression, it's giving us a probability. And based on how high or low that probability is, it's falling under a certain class, and that is what it's being outputted. Why don't we use linear regression for these kind of things? Because linear regression, just like we talked about last class, it predicts continuous values. While logistic regression, it predicts like the probabilities, like these binary outcomes that are being converted to these classes. Like for example, with the student, like test scores, for linear regression, if a student studies for X amount of hours, they could have a test score ranging from either 0 to 100. That's what's being outputted. But in our case, what we're looking at is based on how many hours a student is studying, they're either going to pass or fail. We're looking at the probability of how likely they are to pass, the probability of how likely they are to fail. Yeah, and we discussed this last class too, the difference between regression and classification. So regression, like we talked about last class, is predicting a number. Like just like the example I was just giving, it's predicting the exam score. It's giving us a numerical output from the range of 0 to 100. And then classification, which we're focusing on today, it's predicting a category or a label. For example, just like with the student example, like whether the student is going to pass or whether they're going to fail. It's outputting a probability, which is then being assigned to a class, a label, a category. And then how is this like connected to logistic regression? Because it may be a little bit confusing because logistic regression does have regression in the name, but logistic regression is only using the regression ideas, like the numerical values, in getting the line inputs. Like in reality, it's actually getting like these probabilities, which falls under classification. Like it's not outputting any numerical values. It's just going to output the class, like the value, like either the class or the label, whatever that is, which is based off of the numerical probability. Now that's just gonna jump into like how we like actually do this logistic regression.
All right, yeah, thank you, Naveen. So we just learned that logistic regression is a kind of AI model that is used to predict binary outcomes. And what that means is that it produces a class output from two outcomes. So will a student pass? Will a student fail? Does this person have diabetes? Does a person not have diabetes? It doesn't really give us a number. It just tells us the name of a class that a person or a thing falls into. So how exactly does this work? So let's learn with an example. So Aveen talked about an example where we're looking at students and how many hours they studied and whether they're going to pass or fail. We're not looking for the score because that's what linear regression produces. We're looking for whether they pass or fail. So let's look at how the model works to predict that using that example. The first thing the model does is that it starts with features. So we look at the things that matter for passing. So this is basically our input values. So this could be hours slept, hours spent studying. As these input values go higher, we're expecting a student to have a greater likelihood to pass. The next thing the model does is after looking at these inputs or features, the model calculates something called a weighted sum. So a weighted sum is basically the importance of each feature. So we have different features. The model basically assigns a specific importance score that ultimately shapes the graph of our regression. Now this may be a little hard to understand and I completely get that, but it'll make a lot more sense when we actually code it. And I'll explain to you this picture over here, which will also help you understand this concept. So after it's basically taken all the inputs into consideration and understood them, it applied something called a sigmoid function. Sounds pretty interesting, right? It sounds really complicated, but trust me, it's not. What the sigmoid function does is it takes the inputs, which is our hours studied, hours spent sleeping, and it turns it into a probability between the values of 0 and 1. So in any math class, we've probably been familiar with probability, right? If probability is 0, that means there is a 0% chance of something happening. It's basically impossible. But if a probability is 1, that means there's a 100% chance of something happening. What the sigmoid function does is that it takes the input and reformats it so that it fits between the values of 0 and 1, and it helps us use that input as probabilities. So let's say between 0 and 1, it outputs the value 0.26. We can take that as 26% that a student will pass or fail. And I'll tell you guys how it knows whether it's pass or fail in just a second. But all you need to know so far is that the logistic regression looks at the inputs and reformats them using a sigmoid function between the values of 0 and 1. So it basically turns the values into a probability. After that, the model can decide a class. So based on something called a decision boundary, the probability is assigned to a specific outcome. So what a decision boundary is, it's basically a reference for the model to use to decide whether a certain percent or probability goes to a certain class. So most commonly, I'm sure you're already familiar with this, it's that if you have a 0.5% probability, then you want the class to be pass. So if you have something like 0 0.7, 0 0.8, so 80%, 70%. You want that to fall into the higher class, which would be passed. But if it's something like 0 0.2, 0 0.3, that's a pretty low percent, right? And that pretty low percent typically means that a student is not going to pass. So essentially, think of it like if anything is greater than 0 0.5, is if anything happening has a greater chance of 50%, then you're going to assign it to whatever class. If it has a less percent according to 50, then you're going to assign it a different class. Basically, you're telling it where to draw the line. Okay, after what probability do you want it to change classes? So based on that boundary, the probability is then assigned to an outcome. So example of this would be pass or fail. And then the model continuously does many iterations and learns different weights from this data. So it basically checks its own accuracy, and we'll also go into how it does this in a second. But it checks its accuracy with its test and training output and training data, and based on that, it adjusts the weights or the importance of the feature to make a certain curve that works best for predicting our outcome. So what I mean by this curve is take a look at this picture right here. Okay, you see that it looks like an S-shaped curve. If you were here last week, you know that the linear regression was just a straight line. But this is logistic regression, and it's a curve. It's an S-shaped curve. This is our sigmoid function. Okay, the lowest value, if you can see my cursor, right here would be 0. Okay, the lowest value would be 0. The highest value over here would be the value of 1. So what the sigmoid function did is it took that straight line and it like squashed it into this curvy line so it fits between 0 and 1. And so we can take it as probability and we can use that probability to assign it to a class. So remember Amin was talking about regression versus classification and how regression gives numerical output and classification gives a class. Well, the reason why logistic regression is called regression is because it initially outputs a probability, and then that probability is assigned to a class. And we'll go over this more in detail when we actually code our project. Now let's go into how the loss is calculated. Or when I say how the loss is calculated, I essentially mean how does the model know what to adjust, right? We just went, if you look at the previous slide, we said that it learns the weights from the data. But what does that even mean and how does it even do that? Well, it does that through something called a loss function. And more specifically, it uses something called cross entropy loss. So what this is it basically tells the model how accurate it is in super simple terms. It lets the model know how off its predictions are from what it needs to know. So as the slide says, it measures how far predicted probabilities are from actual outcomes, 0 or 1. So when we say 0 or 1, 0 in binary always refers to false, and 1 always refers to true. So when we have different classes, each can be assigned to a specific number. So basically, the cross entropy loss function penalizes confident but wrong predictions, helps the model learn to output probabilities that reflect reality. So it basically helps the model become more accurate. It's like a grade on a test. Like when you take a bad test and you get a bad grade, you're going to improve on that bad grade, right? The model does the same thing. This cross entropy loss tells it, hey, model, you were this much off and you need to fix this, this, and this. The model takes that and it adjusts its values to make a better fitting sigmoid curve or S-shaped curve to fit the data and generate more accurate predictions. So it penalizes the confident but wrong predictions the most, and its smaller penalties are made if the model is unsure and wrong. And basically, this function, all you need to know is that it helps the model make better probability predictions. It helps the model become more accurate. And this is not something you have to code. It's typically already pre-built into the model that we import, and we'll go into that when we code. But point is, it's really important to understand what's happening under the hood, and this is what's happening under the hood. This is how the model is understanding what it needs to do. And over here is a picture of the formula, and it looks a little bit daunting, but in reality, all you gotta go know is that this log function over here, that one basically takes the probability and transforms it in a way that it penalizes the error, and it finds the sum, basically summation, if you guys are familiar with that. It finds the sum of all the penalized errors. So don't worry, you don't need to know how exactly the formula works, but just know that this loss function or this function that helps the model understand how accurate it is exists, and it's what logistic regression used to make better outcomes and predictions. Now we're going to go into something called multivariable logistic regression. And yes, there's a lot of points on this slide, but don't worry, it's super, super intuitive and simple. So it's basically an extension of simple logistic regression that uses more than one input or feature. So in the real life, most AI models don't just have one input. It's not just as simple as the student studies this many hours they're going to pass or fail. Typically, it's the pass or fail is influenced by many more factors. And examples of this would be our slept, class attendance. You know, if a student studies but barely made class, would they get as high of a score as a student who made every class and also studies? Basically, the point is multivariable logistic regression exists, and it basically takes into account numerous different inputs, not just one. So it combines all the factors to estimate the likelihood of yes or no. And once the final probability is calculated based on the probability boundary or the decision threshold, the final prediction is made. So if you look at here, if the probability is greater than 50%, we're going to give it a pass. If it's less, we're going to give it a fail. And basically, what multiple variable logistic regression does is that it handles multiple pieces of information at once. So moving on, we're going to move into our coding project. And this coding project is going to be super duper fun. Last time we did receive a suggestion to go over some AI libraries that we use, so you guys are better caught up with that. And so we are going to do that right now. So a library, for starters, in Python is a collection of pre-written code that you could reuse. So we don't have to reinvent the wheel. We can use libraries to save us a lot of time and effort when it comes to designing our programs. So what libraries do is that they provide ready-made tools for common tasks like math, data, machine learning, and plotting. And we'll go into the specifics in just a minute, but it helps us write less code and avoid errors. It lets us focus on solving problems and not just building everything from scratch. So, moving on to the libraries that we use in our actual code. For starters, we have NumPy, which stands for numerical Python. So what NumPy does is it helps us with mathematics and arrays, which are just lists of numbers. It's much faster than regular Python lists for big data sets, and we can use it to store and quickly calculate things like averages, sums, or apply formulas. And it also makes it easier for the model to do the same. So NumPy basically helps us easily perform math calculations and store data. Pandas, speaking of data, is built on top of NumPy and it makes it easy for us to work with tables of data. So it basically helps us make things like spreadsheets in Python. It helps us store data in things called data frames, which are basically rows and columns. An example of a pandas function would be to load a CSV file, which would be our data file, and select specific rows and columns to analyze. And when we start coding, you'll see exactly how to do this and use this library. Next, we have a couple more. Matplotlib is a library used for making graphs and charts. So it's really important for us to be able to visualize what's going on in our model, and Matplotlib helps us do exactly that. It works well with the libraries we just mentioned, like NumPy, which remember it helps us with mathematics, and Pandas, which helps us with data. And for example, it could help us plot a line chart of study hours versus exam scores. So it helps us basically give a visualization of our data. Moving on to scikit-learn. Scikit-learn is a machine learning library built on NumPy and Pandas. Now, this library is honestly the coolest library in my opinion. So it basically gives us ready-made tools to apply things like regression, classification, and clustering. And basically, it helps us pull models that are already made, and it helps us just have to train them based on the data that we have. So scikit-learn is full of super useful functions that we have to train according to our data set, and it just makes our process so much faster and so much easier. So an example would be to train a logistic model to predict if a student would pass or fail. Moving on to the last and final one, we have Seaboard, which makes beautiful charts and graphs with very little code. It's built on top of Matplotlib, which, if you remember, we just discussed, is just graphs. It's just easy to use and it works great with Pandas data frames. And it's perfect for showing patterns and relationships in data. So, for example, we could make scatter plots, bar charts, line plots, and heat maps. Now, don't worry if you're like struggling to understand what this is, we will go over how to use them in code so you understand how to actually implement these libraries. Ati, you asked where can you learn these libraries? We can give you specific websites if you would like to more learn these libraries in specifics. But as we code, you're actually going to get to see how the functions work. Basically, learn the libraries while we code. But we can point you to resources after class if you are interested in learning the libraries in more detail. Because the libraries are really, really important when it comes to coding. So let's just go ahead and jump into today's coding exercise. So we understand the basics of logistic regression, and we're going to apply it to a real world problem, which is predicting diabetes. So we're going to apply what we learned to a real data set with real people, and basically, I'm going to give you a quick recap of Logistic just in case you forgot. So with Logistic, we're going to be taking our features, which is our inputs, and we're going to be using those inputs to predict a binary classification, which is basically a yes or no, or basically, in this case, diabetic or not diabetic. We're not going to be producing numbers in this project. So, Avid is going to send out the Google Colab link for us to open. And before you click on that link, I want you guys to do something. So let's just wait for Avid to send that out. All right, so when you click on the link, look at my screen. Don't click on the link yet. Look at my screen. When I click on the link, it looks something like this. Okay? What you need to do is go right here to File and go right here to save a copy in Drive. So make sure you go to File, Save a copy in Drive, and click that. And it is going to make you your own little copy for you to work on. The reason we do this is so that your edits are saved on your own computer and it's not being shown to anyone else. And also that you have your own individual project to go and play around with. So make sure you go and create a copy and you've known that you've created a copy properly when the title says copy of student copy linear regression. Logistic regression, sorry. So make sure you've got it and done that, and I'll give you guys a couple seconds to go and do that. All right, so make sure everyone has made a copy. All right, so I hope everyone did. We're gonna move on to actually coding now, and it's gonna be super duper fun because this is really cool. Let's take a look at our project for today. So we're gonna be doing diabetes projection with logistic regression. And if you ever wondered how doctors might use data to assess a patient's health risk, behind the scenes, machine learning models can actually really help with this task. So in this project, we're going to be training a logistic regression model to predict whether a person is likely to have diabetes based on really key health factors, including number of pregnancies. The reason this can impact diabetes is because there's something called gestational diabetes, which if you're pregnant, you can get more easily because of, your insulin and glucose production. We have glucose level, which is important in diabetes because diabetes is all because of the fact that glucose production can't be regulated. So you have too much glucose in your body, too much sugar in your body. So we have our glucose level to test that. We have our blood pressure, which we are typically looking for a higher blood pressure because if you have a higher blood pressure, that means you have a greater risk of diabetes. We are looking for skin thickness. We're looking for things like insulin. So insulin is the hormone that actually combats uh, glucose, that actually like digests glucose and breaks it down. And if we don't have enough insulin, then we have diabetes because we have too much glucose in our body or too much sugar in our body. We have BMI, which is body mass index. That's basically kind of like body weight. So typically, if you have a higher BMI or higher body weight, you typically have a higher risk of getting diabetes because of your body's ability to produce insulin, which combats glucose. And finally, we have two last factors. We have diabetes pedigree function, which is basically your family's history of diabetes. If your family has a lot of history of diabetes, you have a greater risk of getting that. And we have age. Typically, older individuals have a higher risk of diabetes just because as you get older, your bodily functions get slower. So, these are going to be all of our inputs that we are going to be using to predict if a patient has diabetes or not. Now, you're probably wondering, right? Where are we getting these pieces of data from? Okay, so it seems like Avid accidentally set the solutions notebook. So that is perfectly fine. Go ahead, make a copy of the new notebook link that she just sent out. I'm going to do the same. So remember, it's File, and then click Save a Copy in Drive. Our bad, guys.
Yeah, sorry about that. But it's all gonna be posted later on too, so you'll still have access to it later. But just for the purpose of like the tutorial, we would
Yeah.
recommend you guys just follow along with the Blake one.
Yeah. Also helps if you live code with us, so you get to have a chance to attempt it yourself before you go look at the solutions. All right, I give you guys a couple of minutes. All right, hopefully everyone has caught up. But let's go back to what we were doing. So now we just learned about the different kinds of inputs that we're going to be using to make a prediction. But now you're probably wondering, right? Where are we getting this stuff from, right? Where do you get the number of pregnancies from? Where do you get the glucose level from? Like, are we going to go to a hospital and collect people's data? Well, the answer is no. We don't have to do all that. The awesome thing about AI is that there's so many data sets available of other researchers who've actually gone in and already collected data for us to use. So what we've done is if you scroll down a little bit on the Google Notebook, you'll see step one, which is listed as get the data set. So all you have to do is run that little code cell there. So click the play button. Go ahead and run that. And what that code is going to do, we've already made it for you, is it's just going to go and pull the file for you and load it into your Colab environment. And the reason we've done this is so that you guys don't have to go scouring across Google to go find a good data set for you to use. We've found one for you. And what this code will do is it'll just import that data set in. So go ahead, run the first code cell on this notebook. I'll give you guys like 10 seconds to do that. All right, hopefully everyone has run their first code cell. And the way we are going to know if you guys ran it is go over here to this sidebar that you can see and click the Files button. So down here, you'll see something called Files. So if you successfully ran it, and you should see the file diabetes.csv in your file navigation center. So make sure you guys have that before we move on. All right. So now let's go ahead and explore what we just imported, right? We just pulled this file in from the internet, but what does that file even have? So to explore it, let's double click on the file, and you'll notice that we have a table show up on the right-hand side of our screen. This table is basically all of the data that that file has. So you can scroll around it a little bit. You'll probably see that there's a bunch of columns. They're labeled with the inputs. So our features that we just discussed, like pregnancies, glucose, blood pressure, skin thickness, insulin, diabetes, pedigree function, and our age. And at the end, if you scroll all the way, you'll see something called outcome. And you'll notice that it's just a bunch of zeros and ones. So if it's not working for you, you can look at my screen. As you can see, outcomes is just a bunch of zeros and ones. So if you remember, in our slideshow, we discussed what those zeros and ones mean. Those zeros mean false, and those ones means true. And in this case, the ones mean diabetic, and the zeros mean non-diabetic. So this is basically our final outcome. This is the outcome that we're trying to predict. So the zeros mean that the person is not diabetic, and the one means that the person is diabetic. So those are our outcomes. And this is what we're going to ultimately be trying to predict in this project. So you can look at it a bit, but we're going to explore this data set through code as well using the pandas library in just a second. I'll give you guys a couple seconds to get ready to code. This project is super, super duper cool because it has a lot of real world applications. We can use these models to support the early diagnosis of diabetes, which can help a patient seek early treatment, and they can understand their personal risk and take preventative measures early. And, public health organizations, maybe in your country or US, can identify at-risk populations and give them more resources to help combat diabetes because diabetes is not a fun thing to have. All right. All right, so I think we're all ready to code. So I'm going to pass it over to Avid now, who will get started.
Okay, so now that we've worked with DevStream and we've imported the file of like the data set into our code, the other really important thing that we need to import, just like we talked about earlier, is the Python libraries. So we're going to be importing a couple like different libraries here. We already have the code for you guys, so you guys don't have to like type up this whole thing. But some of the libraries we're going to be using are Pandas and NumPy for data handling, Matplotlib, and Seaborn to like create those plots and the visualizations, and then scikit-learn to like use the logistic regression model and other evaluation tools. So you guys just take a moment to like run the cell, just clicking that play button on the left. And then you know when it's done running when there's like a green check. As you can see, we're just importing all of them. And in case you guys are like a little bit still confused with the libraries, when it says import pandas, for example, it says import pandas as PD. The PD is just like a short abbreviation that we're using. So when we're going to be calling that, referring back to that library later on in the code, it's a lot easier instead of having to like retype pandas or numpy each time. It's a lot faster. I'll give you guys a second to run that. Um, Yeah, we have a lot of different like functions for each of these things, like train, test, split, standard, scale, logistic regression. We're importing all of these, so we don't have to like recode each of these things each time because it would take so long and it's like a lot of extra unnecessary work we have to do. Somebody else has already done it for us, so we're just reusing it and implementing it into our own program.
Yeah, and just a quick note for me to add. If you guys see things like from this, import that, that's just saying to import a specific function from those libraries instead of importing the whole libraries themselves. These libraries have a lot of specific functions. Typically, when you don't need everything, you can just import the stuff that you actually need. So in this case, we're importing things like the train test split, the logistic regression itself, confusion matrix, and standard scalar. And you'll learn what these mean as we code them, but just know that what from does is it basically pulls a specific function from that library instead of importing the whole library itself. So yeah, it's basically specifying what we're going to be using in this program in case you're confused with that.
Yeah, exactly. And now for our next step, like we already went through the data set, like Darcy showed you guys the table, but this is just like another way we're going to be representing it. So we're using the Pima Indians diabetes data set. Each row is like equal to like the patient's health information, like glucose, blood pressure, BMI, if you guys remember the table that we just looked at. And then each column sorry. Yeah, each column is like, oh no, there's one column for the outcome. That's the target column. That's what we're trying to have the model predict. So just like we talked about too with logistic regression, it's a probability. It's outputting the class. So it's going to give us either 1 or 0. 1 means that the patient is diabetic, and then 0 means that they're not diabetic. So just to like code a little bit, just to like show the like first couple like data points, we're just going to be doing df. We're going to create a variable df, which is short for data frame. And then we're going to implement the pandas file, the pandas library that we imported earlier. So we're just going to do pd dot read underscore csv. And then in those parentheses, we're just importing like the CSV that we had from earlier. So yeah, we're implementing the pandas library. And then this variable, what it's basically doing, this function, is just loading our data into a data frame. A data frame in Python is just basically like a spreadsheet. So in this case, the rows are going to be the patients and like all of their information. And the columns is like each of the like different information, things like BMI, glucose, age, all of those different features. And then to print out like the first couple rows of the data set, we're just gonna start with like a header, like print out first 5 rows. And then we would use print df dot head and open close parentheses, which that's showing us the first 5 rows of the data set. And then we would just do print df dot info open close parentheses. That just like gives us like a summary of the data. We have some questions. Evelyn asked, I found out during the last class that if you move. Oh,
Oh,
okay,
that's
that's
pretty
really cool.
interesting.
Yeah, that's really interesting. I didn't know that. And Hannah's asking PD in this case. Yeah, PD in this case is pandas.
Yeah, so if you
So
go
if
up,
yeah, if we go back up to the import cell, We see import pandas as PD. Basically, we're just like abbreviating it. So once we like, whenever we need to refer back to that pandas library, we're just using PD, and we can use any of the functions from there.
We're
It's just
basically
referring back to
renaming
that.
it.
Hmm.
Yeah, so if I change this right now, Hannah, if I change this PD to anything, like if I made this Hannah, if I said import pandas as Hannah, and I go down here and I say Hannah.read CSV, it will work. Because that, when you import it with something called as, it basically gives it a shorter name for you to use, and you can make that anything you want. So whenever you see import this library as whatever name, it basically makes it faster for us to code because it makes the name shorter. Because writing out, for example, matplot dot pyplot dot something, it just makes everything so much more confusing. So that's why we give things shorter names so it's really easy to implement and understand. And you're asking how it implements the library. Well, read underscore CSV is a function of pandas that we imported, and it basically is pulling that function from that library and applying it to the file. And it's turning the file into a variable that we can feed to our model, basically, if that makes sense.
Okay, yeah. And like hopefully if you guys are coding along with us too, you guys are just like typing up whatever we are like typing over here. Or if you guys are just like watching and you're gonna go back later and do it yourself, that's totally fine too. All of this is gonna be posted. So now that we're printing out the first 5 rows, our next print statement is just gonna be print df.info and open and close parentheses. This print statement is just giving us like a basic summary of the data set. It's like instead of looking at the actual data, it's just looking at like the labels and the structure of the spreadsheet instead of like the actual patient records. So then if we run this cell, we can see it outputs like these different charts. So the first one is the first 5 rows. It's just looking into that same table. It's the same thing. And then if we look down at the data set info, it's giving us like about each of the columns, it's telling us about the data type, and it's just giving us more information about that. I'll give you guys a second to run that.
Yeah, and while you guys run that, if you guys are curious as to what things like non-nulls are, that's basically telling you how many actual pieces of data in there. Because in reality, when you like do research, if you go out to find different data sets, you'll find that many of the values in some of those data sets are actually listed as something called null or NaN, which means that they don't have any values. Like they're just empty values. And that can actually skew a model's prediction. And we always want to combat that. So this is a good way to see if there's any of those non-nulls existing. So as you can see, all of our numbers are the same and they're all non-nulls. So that means that we have no nulls or nothings in our data set. So this is just a good thing to look out for when you're doing research, when you're going and exploring different data sets. Nulls are not good. We do not want to see nulls. Yeah. So this is just this entire step that Amin just talked about, awesome, is just data exploration. So this is not doing actually anything to our data yet. We're just exploring our data. It's really important to have a good idea of your data. Hannah, you have a question? You raised your hand.
Yeah, so you were mentioning the null, so I'm actually doing research, so this is very interesting for me. How can I get this like feature, I guess?
How to see if you have nulls or not?
Yeah.
So to do that, we just did dataset.info. So you see over here this last line of code, Hannah, this one? It
Yeah.
says df.info. So that stands for data frame dot information. So it just gives us information about our data set. So if you look down here, right? It printed all of our non-nulls and everything, all the information about our data set after our print statement data set info. So if you just do dot info like this,
Yeah.
it will tell you your non-null count.
So that's just from one line. Wow. Okay.
Yeah,
Oh, you just
one
have
line.
to like make sure that you're referring back to that variable that like the df that when we like define using the pandas library, it's just looking back at that. That's reading the file. And then once it's reading the file, we just use the .info function, and that's what's gonna output all of these like different characteristics, like the non-null.
Yeah, okay, thanks.
Okay, perfect. And now moving on to step 4, we're gonna be looking at like the features and the target. We're gonna be defining some variables for that. So for the first variable x, Um, so basically we're creating this variable x. This is gonna be for the input features. So we're just gonna doing x is equal to data dot drop, and then in parentheses outcome, comma, axis is equal to 1. So to break this down, basically what we're doing here is we're taking this data set and removing the column outcome. Outcome basically in this data set, it's the answer, right? It's what we want the model to predict. So we want it to tell whether the patient has diabetes or not. So that's why we're going to remove it because that's like what we want the model to do. We don't want to give it the answer while it's training it. We want it to learn to predict it. Um, that's what that's what we have outcome. It's referring to that column. And then axis equal to 1, it's basically just telling pandas that we want to drop the column. If we made it axis is equal to 0, it would mean that we're dropping a row. So once we define this variable and we use this function, x now has everything except the outcome column. So it has like all the different columns like the glucose, BMI, age, etc. It has all of those columns besides outcome. And looking at our y variable, this is like the target, this is the output, this is what we want to predict. So in this case, relatively, what we want to predict in this case is like, what is the outcome going to be? That's what we want the model to do. We would just do y is equal to data, and then in brackets, outcome. So what like this outcome column too, it's just made up of these two different variables, either no, sorry, not variables. It's made up of these two different like classes. One is equal to the patient has diabetes, and 0 is equal to the patient does not have diabetes. So if you guys just take a moment to like copy this and like run the cell.
Yeah, and if you guys are getting things like syntax errors or things like that, just make sure you've copied the code exactly as how we've done it. And if you're getting any other errors, just like free feel to let us know. But oftentimes we found that last class when most people got errors, it's pretty much because they either misspelled something or they, typed the wrong variable name or something like that. So just double check that. Do try to debug yourself before you send it to us, just so you guys get practice debugging, because that's also a big skill.
And this cell too, once you guys run it, it's not going to necessarily output anything, but it's just working like behind the scenes. We're just like in our data set, the X value has all of the other columns aside from the outcome, and then the outcome column is being stored in this Y value.
Yeah, this step is really important because what Avid has just explained here is actually defining and splitting our data into an X and Y. So we're splitting what we want to predict from what we want to give the model. So just think of it like that. That's all that this code is doing.
So hopefully you guys got a second to like run that and stuff. And yeah, just like continuing on from what Debshi was just saying, in our next step, now we're going to be doing is splitting the training and testing data. So now we've split the inputs and the outputs from the X and the Y. Now we're going to split it a little bit further and create the training and testing data. So if you guys remember like last class with linear regression, honestly, we did the same exact thing. So we're basically just like splitting our data set into two parts. 80% is going to be used to train the model and 20% is going to be used to check the accuracy of this like unseen data. That's what like the model is going to be predicting the value for this other 20%. So in this line of code, we're going to be creating four different variables: x underscore train, x underscore test, y underscore train, and y test. So x train is like the training features that the model is learning from. X test, these are like the features that we're going to test the model to check up later on. And then like the same thing for like Y train. Y train is like the training answer. That's the correct diabetes outcomes referring back to that like X train, like the training data. And then Y test is the correct testing answers referring back to those like it's giving us the correct diabetes outcome for the testing data. So like the X train and the Y train they go together, and then the X test and the Y test like they go together. And so this is equal to train underscore test dot split. We're just using this function referring back to that like import statement. And then in parentheses, x referring back to that variable we just created in the previous code cell, comma y, that same thing. That's also referring back to that. And then test size is equal to 0.2, comma random state is equal to 42. So the test size is basically just telling us that we want to use 20% of the data for testing, so the other 80% is used for training. That kind of ratio is just kind of like, it's just like common. Everyone really uses that when it comes to separating your data. And then random state is equal to 42. This is just the number that we set to ensure that like it's being split at the same time, like for throughout the code. And then 42 is also just like a common number that most programmers use. So if you guys a second to like copy that down and run that.
If you guys have any questions at all, feel free to ask. Okay, we're here to answer your guys' questions.
Mhm.
Ati asks, if you change the test size, does it affect the final answer? And the answer is yes. So the thing is, your training test split is really, really important because it basically divides the data and gives the model something to learn from and then something to test what it learned from. So if you make the test size like let's say 40, right? So if I change this here to 0.4, now our test size is 40%. But now our model only has 60% of the data to learn from. So it has less things to learn from. Okay, it has less data to learn from. So the obvious thing is that when you give your model more data, it's gonna learn better. Cause right? Cause you have more things to learn from. If you have a math test tomorrow, you practice more, you're gonna do better, right? But if we increase the test size, that decreases how much learning data the model has. Okay? So when you decrease the amount of learning data the model has, that decreases its accuracy. So, like a good split would be like 80% for learning, 20% for testing, or 30% for, or like 70%, 30% is also fine. But I don't recommend going 60/40 or anything like that. It's important to have a good balance. The model needs more data to learn from than to test on. So, it's a good convention to have this as something like 80/20, like we have here.
Yeah, I think if you guys have all gotten that like down to, if you guys have any questions up to this point, let us know because this is all like really important to like actually being able to implement the logistic regression concepts. But if you guys are good, then I think Devshri can continue on. What does it mean to test the data? So basically, like, so just like we're like breaking this down here. So we have the 80% is what the model is training from. That's what it's learning. And then when it comes to testing the data, that's what the model is going to be actually like predicting the values for. Like that's what it's going to be outputting. That's like the whole point of what we want it to do.
Yeah, so like Avid said, the model learns from data, right? The model has training data, which I'm assuming you understand. So training data is what it like learns from, right? But then how do we know if it learned properly? How do we know? The answer to that is by using the testing data. So we've set aside a piece of the data to evaluate the model's accuracy on. So when you're like when you went in school, right? You do school, right? And you in class, you learn a bunch of stuff. That's you getting trained. That's like you getting trained. And when your teacher hands you a test, that's what the test data basically is. It's testing what you've learned so far. It basically gives the model something to evaluate its accuracy on. Because the testing data has the right answers in it as well. So basically the model predicts something and then it's graded. Think of it as like a graded test. The test is graded and then it model knows we can see the model's accuracy through that testing data. So basically testing the accuracy. Okay, awesome. All right, Abid, ready to hand it off to me?
Hmm.
All right. So far, so forth, we've only worked with our data, right? We've split our data, we've split our prediction from our input variables or our features from our targets. We've given the model something to train on, something to test on, but then let's make our model, right? Time to make our model. So we have one step left before we do that, and that's something called standardization. So standardization is really, really important. So what standardization is basically scaling all of our inputs to a similar scale. So all of our inputs so far have a widely different ranges, right? There are different units, right? Your insulin is not going to be measured the same way as your body fat is, right? So that means that our numbers are really big and really small. They're varying all over the place, right? The model can sometimes take this and get confused. It doesn't always know how to evaluate different units. So the way we fix that problem is by doing something called standardization. So what does the word standard mean, right? It's like a common thing all throughout anything, right? It's something that stays common. What we're going to be doing is we're going to be applying standardization to our data and making basically their means the same and their standard deviation the same. So I know these are big words that I'm spewing out of my mouth, but to put it super simply, we're trying to basically minimize the range of our data and make all the data or all of our inputs in a similar scale to one another so that the model is easier, so it's easier for the model to understand the data and successfully make a model. So let's get into how we do this while my monitor turned off. All right. So the way we're going to be doing this is by through a function called standard scalar, which we imported earlier. So let's see how to do this, right? So first of all, we have to make a variable called scalar to define a object of the function or of the class standard scalar. So I know these are again technical terms, but all we're doing is pulling the standard scalar object to apply to our data. So go ahead, make your object. So it's just scalar is equal to standard scalar with two parentheses with nothing in it. So this is just pulling, just think of it as like getting the function, getting our standardization function into our code as a variable. So go ahead, type that up. All right. Hopefully everyone has gotten a chance to type that up. Now we're going to actually apply what we've just imported, right? The way we're going to apply it is first we're going to apply it to our X trade data. So remember we already made this variable earlier? You're probably like, wait, we already made X trade. What are we doing, right? But the thing is we need to update that trading data with the properly scaled data, right? So the way we do that is doing X trade is equal to scalar dot fit underscore transform X underscore trade. So what this line of code is doing is updating the value of X trade with the standardized values of that trading data as it was originally. So we're taking X trade, standardizing it, and assigning it back to X trade again. So all this line is doing is updating the value of the variable X trade that we made earlier. When we split the data, we made our X trade, right? And now we're updating it with the standardized version of it, with a similar scale of all the inputs. So the model knows and isn't getting confused that, wait, this one is 160, but this is only 2. Does that mean that the 160 is more important than this? Like, this basically helps it generalize everything. So go ahead and type that up. And once you're done, we also have to apply this to our testing data. So we're going to do the same thing with the variable x test instead. So we're basically turning our x's or our inputs into the similar scale. All right, any questions, anyone? Did everyone get that successfully going? Go ahead and press the run button to make sure you have no errors. All right, I'm assuming everyone has gotten it since I don't see any issues. Let's move on to actually training our model. Now, it's a lot easier than many people think at this stage. And all we have to do to first train our logistic regression model on our data is first start by pulling the model itself, right? We need to attain the untrained model first. So to do that, we're going to create a new variable called model. And this model variable is actually going to store our untrained model. So just go ahead and do model is equal to logistic regression like this. And inside, enter a variable called max iter is equal to 1,000. So looking at this, you're probably thinking, what does it do? So what this line of code is doing is it's pulling an untrained model. So basically a super flat model that has nothing in it, no data, no training, no inputs, no outputs, no nothing, and it's just assigning that to a variable. So it's basically like a blueprint a blueprint that we are going to train ourselves. And in that blueprint, we have the variable max, oops, I spelled it wrong, max iter, which basically stands for max iteration. So we're just telling it how many times it should keep training before it gets a good, accurate prediction. So this is just how many times we want it to train. Think of it like how many practice tests you want it to take. Go ahead and import that. And the next thing we have to do now is train the model, right? How do we put our data inside the model? We have this model variable, we have our X trade or our Y trade or our test or blah, 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 blah. Like, how do we combine them, right? The way we do that is by doing model dot fit X trade, comma, Y trade. That's it. So what this line of code is doing is it's fitting that untrained model to our training data. So this is our X trade, which is basically the inputs or the features. So if you recall, that's going to be our number of pregnancies, glucose level, blood pressure, all of this stuff up here. And our scroll down, our Y trade is going to be the outcomes that we set apart for the model to learn from. So the zeros, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, the non-diabetic, diabetic, non-diabetic, diabetic, so on and so forth. So this basically just fitted our model, our logistic regression model that was previously untrained, to the specific data that we are using. So it's pretty cool. So go ahead and run that. Make sure you guys are not getting any errors. You might see this little output that shows up. That's just letting you know that it created a model. So that's just a good indicator to show you that a model has been successfully created. All right, assuming everyone is good to go, since I don't see any questions, let's go ahead and make a prediction now, right? We have this model that's been trained many, many, many times on the training data, on that 80% of data that we set apart, right? But now we need to use it, right? We need to use it and apply it to our testing data. So the way we do that is we make a prediction. So the way we make a prediction is start with a variable. We do y underscore pred, which stands for y underscore prediction. So the prediction of our outcome is equal to model dot predict x underscore test. So this is a good idea. This is a good point for you to stop and understand what the test is used for. You can see that we're using the testing data to make a prediction now. So go ahead and write that up. All this is doing is it's using the functions from the scikit-learn. If you guys remember that scikit-learn library that we imported, it's using this function from that library to make a prediction. You guys can run that. No output's going to be produced just now, but in the next code cell, we're actually going to be able to make a prediction and see what the model is doing. So we've made a awesome, cool design for you guys to run and understand what the model is doing behind the scenes. So let's get started. So the first thing we have to do is give the model an example input, right? Now we're going to be making the model predict from inputs that it's never seen before. So until now, the model learned from the training data and tested its accuracy with the testing data, right? But now what if we give it brand new data that it hasn't seen before and it doesn't know the right answer? Brand new data that it needs to go and find the answer for us, right? So let's go ahead and do that. So we're going to be making our we're going to be feeding it a set of values. So number of pregnancies, insulin, etc., etc., etc. We're going to call this variable example. Honestly, you could call it whatever you want, but we're going to name it example for the sake of this. So Hannah asks, what makes a part of a code give out an output? Some parts here don't give an output and some do. Some parts here give an output and some don't. Why? That's a great question, and it really has to do with how the function is made. So if you look at like this function here, right? Dot predict, if I run this, it doesn't give us any input. That's because the people who made dot predict didn't code it so that it gives input. Sorry, that it gives output. So when these functions were made in code, they were either made to give input or not. And some are you could give input through print functions. Typically, these models just print, or these functions just print. But the reason why, essentially to answer your question, the reason why some are giving it outputs and some aren't is just because of how they're made. And the lines of code that typically give output are things like print. And we can't really change this because remember we're importing this from someone else's code, so the libraries. But if they had added print statements, then these would give it outputs. There's also things called called fruitful and void functions. So fruitful functions are return, they basically return a value and you can print it. But don't worry about that now because these functions are not these you don't need to understand that to understand these functions. But point is, it's just yeah, it's just how they're made. Okay, moving back, let's give the model some input. So I'm going to put a lot of numbers. So I might copy paste this into the chat so you guys can just paste it. But watch how I'm coding this. So we're going to do np.array. What does np stand for? Np stands for numpy. Remember, we imported numpy as np. We're going to give it an array, which is kind of like a list, but it's just more functional. And we're going to give it some numbers. So the numbers I've chosen is 6, 148, 72, 35, 0, 33.5, or 33.6. I'm looking at a list here. 0.627 and 50. So it's a bunch of numbers. I will copy paste this for you guys so you don't have to write down this. Let me just double check our values, make sure we have all of them. And what this is just a uh it's just an array so that we can feed it to our model. So I'm going to copy paste this for you guys and add it to the chat. You guys can just paste that so you don't have to write down all the numbers. But point is, we're basically making an example or basically creating a new input for our model to predict the output for. So if you're wondering, well, what do these numbers even mean? Well, if you go up and you look at our data, like the number of pregnancies, glucose level, that's what all this is. So let's say this person has 6 pregnancies, their glucose level is 148, their blood pressure is 72, their skin thickness is 35. These are just arbitrary numbers that I just made up. So, but these each of these numbers correlate to a specific feature or input. Okay, so hopefully everyone has gotten that up and running. So if you run it, make sure you have no errors and we can move on. The next step right here is to scale the features. So remember what we talked about, how we need to scale our features before giving them to the model so the model doesn't get confused that, oh, this is too big of a number. Oh, this is so small. That means that the bigger one means that this is going to happen. We don't want it to make stupid conclusions, right? So we're going to scale our data to make everything relatively in the same playing field. So the way we do this is we're going to make a new variable called example underscore scaled is equal to scalar dot transform example. So this code is basically transforming the the array into a standardized version. I mean, we have some questions in the chat if you can consider, if you can continue answering as I continue to run this. So make sure this works. I seem like I have an error here. Let's see what's going on. Ah, just give me a second, guys. Spelled scalar wrong earlier, so make sure you guys also didn't spell scalar wrong like me. Go back to step 6, make sure you spelled scalar like this. And change, if you spelled it wrong, then go ahead and change where it's been referenced like that. Okay, let me know if you guys got any errors, because I know what just happened was confusing. But all I did was I accidentally spelled scalar wrong earlier, so I went back and I renamed it to the proper spelling of scalar, which is SCALAR, and that made my code work. So it's little things like this that you guys should develop. Like debugging skills are really important. Like read the error, go back, and understand your mistake. But if you guys didn't make that mistake, we're free to move on. All right. So now that we've scaled our inputs so they're all in the similar playing field, let's get the probabilities of every class. So remember how we talked about how logistic regression predicts the probabilities of something, happening? How we have that like S-shaped curve that fits all of our data between 0 and 1, and it sends us the probability, and based on that probability, it gives it a class. Well, that's exactly what we're going to be looking at right here. So let's start by getting the probabilities of each class for the specific input. So we're going to start by making a variable called probabilities, and we're going to do model.predict underscore proba example scaled. So always remember wherever we're getting, if you're wondering where we're getting these random functions from, it's all from those libraries that we just imported. So this is from scikit-learn. Remember scikit-learn, the one that gives us our model, all that? This is called predict proba, which stands for predict probabilities, and basically it predicts the probabilities for logistic regression. So what this line of code is doing is it's going to go ahead and with the data, it's going to put it into our logistic regression function, and it's going to return to us the values of the probability values of each class. So both the values should add up to 1 at the end. So I'll give you guys a second. All right. Let's keep going. Now we're going to go ahead and make a real prediction. Now we're going to have our model predict something. So we gave our model the data, right? We gave it the properly scaled data, but now we want the model to give us an output. So the way we do that is make a new variable called prediction is equal to model.predict example underscore scaled. So this is going to take all of our scaled input and go ahead and make a prediction. So this prediction is going to tell us if it's diabetic or not diabetic. So it's going to give us 1 if it's diabetic. It's going to give us 0 if it's not diabetic. So that's how you can assign it to a class. All right. So hopefully everyone got that. But now let's think logically for a second, right? Use your coding knowledge. We have this prediction that has either 0 or 1 in it, right? Because our model was able to predict that using the data that we gave it. But how do we check if it's diabetic or non-diabetic now? Think about it. The prediction is either 0 or 1. So how do we output that the person is diabetic or non-diabetic? You guys have any ideas? Kind of gives you a hint right here. Yeah, yeah, there you go. You guys are getting it. Perfect. So basically, we have to decide the label using an if statement. So we're going to do if prediction of 0. The reason we're doing 0 is because all this is arrays. So the array is going to have either 0 or 1 in it, okay? So if prediction of 0 is equal to 0, then the label is going to be non-diabetic. So go ahead and write that out. Else, the label is going to be diabetic. So what this code is doing is it's going to be checking what's inside the value of prediction, if it's a 0 or 1. If it's a 0, it's going to let you know that the label is not diabetic, so the person is not diabetic. But if it's not 0, if it's anything else, it's going to be a 1. Then it's going to let you know that the label is going to be diabetic. So pretty self-explanatory. Yeah, so good job, Athi, Ishan, great job. All right. So now that we've made our little conditional, it's called the conditional for those who don't know here, we have to show our results, right? So let's print an informative print statement to output our findings. So we're going to go ahead and say print probability of being non-diabetic comma, probabilities, 0, 0. And if you guys are confused as to why there's two of them, I'll explain in just a second. But just copy this code for now. All right. So go ahead and run that. So as you'll see down here, the most important thing that you have to look at is the final print statement here. Honestly, these are not even that important. But if you run your code and you see your final prediction, if it says diabetic, that is going to be the model's prediction for our for this project. So as you can see, based on the data, the model predicted that this person is diabetic. We'll give you guys a second to look at that. And we only have one more step left, so we have a little time remaining before our interview starts. So we're gonna go a little slow with this. And we'll also give you guys some free time to go ahead and code and explore on your own and ask us questions. All right. So moving on. Let's go ahead and create a little bit of a visualization of what just happened. So now we got our model to predict something, but how do we see its accuracy? Now there's a lot and a lot of different ways you could go about this. We're going to be only going over one in this because for the sake of simplicity, we're going to be going over something called the confusion matrix. So this is something called the heat map, and it's if you look at research boards and things like that, um Evelyn got an error. Okay, let's look at your error for just a second. Huh, okay. Uh, I would need to look at your code to go ahead and look at why that error happened. So if you could just hold off for a little bit, I'll send out the solutions in just a bit, so you guys can look at that. But just give it a second, Evelyn. You can look at my screen for now while I explain. But I can help you fix your code if I can see all of it later. But let's move on just for now. So we have our confusion matrix of heat map. And basically what this is going to show is how much the model got right and how much the model got wrong. So based off our test data. So what we're going to do first is create our matrix. So this is kind of a long piece of code. So if you guys need time to do this, I will give you time. But it's hard to show you guys what a confusion matrix is before we actually make it, but it's gonna look really cool once we actually do. So if you guys look at research posters and research projects, they many times they will always have this heat map on there. So if you ever look at this like square thing and you're wondering what is that, you can always remember us and be like, oh, I learned this in Youth XAI's class. Um, but let's see how we can make one. This will basically show how much the model got confused in a way. So let's get coding. So first of all, we have to make our confusion matrix. So we're going to do CM, which stands for confusion matrix, is equal to confusion matrix y test y prep, like this. So this confusion matrix is a function that we imported earlier from scikit. And what this is doing is basically defining that we want a confusion matrix based of how the y test outcomes were and how the y prediction outcomes were. Now we actually have to give our confusion matrix a physical representation, right? We want to see it in real life. This is not going to do anything. Like if I run this, it doesn't output anything. We want to see something, right? So we're going to use Seaborn. which is another library that we imported earlier. So Seaboard is a library that actually allows us to make really beautiful graphs, honestly. So we're going to be using this. So we're going to do SNS, which if you're confused about is how we named Seaboard. So you don't have to type up Seaboard every time. So we imported Seaboard as SNS. You're going to do SNS.heatmap. And you're going to do CM, which is that value or that variable we just made earlier. That's our confusion matrix because we want to make a heat map of that, like a physical representation of the confusion matrix. So that's our CM, and then we're gonna give it another parameter, which is annotate is equal to true. So what annotate stands for is annotated or annotation, and that just shows what you want to always have that to true so you can see the numbers on the graph. Because if you don't have annotate to true, it's not going to show you any numbers. You're just going to have squares. You're going to be like, what is going on? So annotate stands for annotation, and you want to set it to true so you can see numbers on your heat map. Next, we're going to do FMT is equal to D. And what this is, it's kind of a weird notation, but FMT basically tells you that you want your numbers on the graph to show up as integers. So it's just basically giving you a data type. So if I were to change it, I could make it a float. So it would be as a decimal number, things like that. But FMT stands for format. And it's just letting you know that I want integer numbers as on my graph. Give you guys a second. All right, next parameter, we're almost done, is CMAP. CMAP stands for color map, and it basically allows us to give our graph color. So we're gonna do blues for this because blues is typically the standard convention. Most people do blues. So we're gonna do blue too. So just do CMAP, color map is equal to blues. And we have two more left. I know it's a lot, but this one function does a lot of things. So we have to give it things to work with, right? Next thing we're going to be doing is giving it labels, right? You always need to label your X and Y axes. So we're going to do X tick labels is equal to non, so this is going to be a list. Non-diabetic, comma, diabetic, like that. And then we need Y tick labels, which are going to actually be the same thing. So you could just copy paste that and replace the X with Y. All right, give me just a second. But yeah, just type that in. Let me just format this a little bit easier for you guys to see because I realize that it can be a little bit confusing. So I'm just gonna put every parameter on its own line. So all I did here was I created a heat map and I gave it a bunch of parameters. So just to review, CM is our confusion matrix. So we're inputting the values of our confusion matrix into this heat map. Anna equals true basically makes our graph show numbers. Format basically lets us know that we want integers showed. CMap is basically color map. It's just the color that we want on our graph. Really simple. It can be anything. X tick labels and Y tick labels are basically the labels that we want. And I know looking at this, you're like, why are we labeling the both X and Y the same thing? Well, when you look at the heat map and I explain to you what it actually means, I guarantee you're gonna get a better understanding of what this is. All right. So I will copy paste this just for you guys because I know this is a lot of code. So I will throw this into the chat if you need to copy paste that. So go ahead and run it to make sure you're not getting any errors. All right. I don't see anyone in the chat say anything, so I'm assuming we're all caught up and ready to go. Couple more things. First, let's go ahead and oh, Hannah, yes, you have a question?
Yeah, so I noticed that you were like talking to us as if the code isn't already there because, in the copy that I made, the code is already written in the parts, I guess, or in the
Oh,
examples. So we
uh-huh.
never had to type anything.
Okay, yeah, that's okay. Those so Avid accidentally sent out the solutions earlier before the blank notebook. She sent out the blank notebook after that. So I think you're on the solutions notebook, which is perfectly okay because we're gonna send it out to you anyway. But if you look in the chat, if you scroll up, she sent out a second notebook, which is the blanks. And in that,
Oh
people
yeah,
are typing. So
yeah,
don't
I
worry.
see it. Yeah.
Yeah, you see it? Yeah. So that one, you can use that to actually submit for your assignment. But it's okay if you've been following with the solutions so far. That's perfectly fine. Like, don't worry about it.
Okay. Yeah. Thank
Yeah.
you. Yeah.
You're welcome. Okay, moving on. We're gonna actually add two more labels now, just on top of it, so you can understand the heat map a little bit better. Uh, so we're gonna add a x-axis label. We're gonna do plt.x label, and we're gonna call it predicted, and we're gonna make a y label. And I know this might not be like visually intuitive so far, just because we haven't seen the graph yet, but I promise I will explain to you what's going on as soon as the graph is made. Do the same thing with y label, so but except make it actual like this. This is we're using the matplotlib library. And finally, we're going to add a title to our entire graph and call it confusion matrix. You want to always title your graphs. It's a really good convention to do. If you ever take things like AP biology and things, if you don't title your graph, you will lose points. I'm telling you from experience. All right, and finally, we're going to display our plot because we want to show our plot, right? So it's as easy as doing plt.show, and that's just plot.show. It's going to show our plot. Do you have a question, Justin? I see that you underlined something. Feel free to type it in the chat, or you can, yeah. All right. No? Okay, that was an accident, I'm assuming. All right, so let's go ahead and run our code cell, and you'll see, whoa, what is this, right? Do you see this really cool looking uh square thing show up? Looks really interesting, right? What does that even mean? I'm sure you're wondering. So what this is basically a visual representation of what the model got right, what the model thought it got right, and what it actually got wrong, and basically all different combinations of that. So I'll explain to you in just a second. First, let's take a look at our labels. So on the left side, our y-axis, we have diabetic and non-diabetic. Okay, you see here? Look at my screen. You guys can take a break from your screens for now. Look at my screen. We have diabetic and non-diabetic. And then on top of that, we have actual. Okay? And if you look down here, we have non-diabetic, diabetic once more, but then we have predicted. So anything in the predicted row is going to be things that the model thought it got right. Okay? Anything that's on the actual rows are the actual outcomes. So let me just put it super simply. Let's look at the top left square of this confusion matrix, okay? You see that it has the number 79. So what this box represents are the number of outcomes that the model predicted correctly and were actually correct. So the number of outcomes the model predicted as non-diabetic and actually turned out to be non-diabetic. So this is basically showing you the accuracy of the model. So the left square is telling you how many people were actually non-diabetic and were also predicted as non-diabetic. And remember, we're getting this with our test data. So this is basically this is like a report card. Think of this as a report card for our model, like your exam scores, how they tell you every subject how you did. Think of this for the model. So the top left square of this confusion matrix is telling you how many predictions the model predicted as non-diabetic and were actually non-diabetic. So this is a good. We want it to be, we want the square to be big. You see that the number is way higher than the rest? That's good. Does anyone have a question? I see someone's unmuted. Are our confusion matrices supposed to be the same as yours? Is yours different, Dia? How is yours different?
Mine on the like left right box, it's showing 0. So
Oh,
the
really?
report card is not very good.
Oh no. Okay. So which box? Is it top left,
Top left.
top left? This one?
Yeah.
Okay. So the reason yours is also different. Okay. So the reason I think that that might have happened is because of some of the variables that we're putting into our function. Oh, interesting. Seems like a lot of your guys are different. Okay, no worries. Are you guys making your own notebook or are you guys running the solution?
I'm making my own, and that's how they're.
Okay, so you're making your own and it's not working.
I
All
think
right.
another reason that it could be different too is because like if we think back to when we like split the training and testing data, it kind of does it like a little bit randomly kind of too. So everyone's model is looking at different pieces of data, and based on that, like the logistic regression model, when it makes its predictions, it's gonna get a little bit of different values. So it's totally normal if you guys are getting different numbers. It's just like a way of evaluating how your model, like personally, like how that's doing.
Yeah, Avid is right, but I don't understand why you guys are getting zeros. Like, you guys should not be getting zeros because that shows that the model is not learning very well. So we'll look into that in just a bit. I think what I think happened with your guys' code is that some of the variables, you know how we made like a bunch of variables? I think maybe you guys substituted a certain variable for something else at some point of time. You guys, how about you go and we already sent out the solutions notebook, right? Why don't you guys go to the solutions notebook and compare your code as soon as I'm done explaining the matrix? Okay? For now, I'm gonna explain the matrix just so you understand what it should look like, okay? And then once I'm done explaining, you guys can check against the solution notebook and then find the error. And if you guys still can't, then show us your code, all right? Because it's always good for you guys to debug yourself and understand before you show it to us, because that builds your guys' independence. So just look at my screen for now and understand what the confusion matrix is, and then later go with this against the solution and then see what that's happening. So looking at my confusion matrix, which doesn't have any zeros, um, the top left box is showing how many people the model predicted as non-diabetic and were actually ended up being non-diabetic. So you want this to be a higher number. The bottom box, however, is the amount of people the model predicted as non-diabetic, but they were actually diabetic. So we can see that our model has some flaws, right? It's not a perfect model because obviously you have to give it more training data. You have to do a lot more editing, tweaking here and there, which I would cover, but we don't have time for that in this lesson. But the point is, the majority of its predictions are accurate. You can see, right? The 79 is greater than the 18 by a lot. So this comparison shows you that our model is doing a great job. On the right side, we hear the bottom right box here is showing how many people the model predicted as diabetic and were actually diabetic. So you can see here, right? Predicted diabetic, 37, were actually diabetic, also 37. So this means that the model did a good job of predicting how many people were diabetic as well, compared to the amount of people that it predicted as diabetic and actually ended up not diabetic. So these 20 and this 18 are both values that were predicted wrongly by the model. So basically, you could think of that. And these two were values that are predicted rightly. Now, one important thing you might notice is that there's different shades of blue on this graph. And the blue of this graph is basically why we call this confusion matrix a heat map. Basically, the higher the number, the darker the shade of blue it's gonna be. So what you want to look for is like sometimes like when you have like say you're doing a research presentation, just for an example, and you have this heat map. The judge is not gonna come looking at every little number on your thing, right? They want to look at the visuals. So the big great visual that this confusion matrix gives is that the darker the blue, the higher number that that box is gonna have. So it's really good that these two boxes are darker blues than these two boxes, which are basically really, really light blues. Like these two boxes, like the inaccurate predictions are the lightest that they can be. But these two are pretty nice and pigmented, right? So that shows that our confusion matrix has successfully worked. And I know some of you guys have gotten some odd numbers with your confusion matrix, which I'm really curious as to why that happened. So you guys can actually send your guys' notebooks if you guys are unable to find the problem. So try to find it yourself first. If you guys still can't find it, send it over. I will help you guys. We at Avid will help you guys. And yeah, what I think happened with your guys' code is that you guys put a wrong variable in the place of something else. Is anyone else also getting that error, or did anyone else get any values similar to mine? They don't have to be exactly like mine, but did they get something like what I'm having on my screen here? Or did everyone get zeros? If anyone else could just let me know in the chat. Okay, I don't see any responses. That's perfectly fine. Just compare against the solutions and see. Bhavana, on the top I got 89, top right I got 13. Yeah, Bhavana, that seems perfectly right. Okay, Aarti got the same solutions. Bhavana, it seems like you fixed your problem. So, or Bhavana, you never had a problem, did you? Oh yeah, you did. Wait, yeah. So Bhavana, what did you do? Because you were saying that you were getting odd numbers and now you seem to be getting great numbers actually, even better than mine. Let us know in the chat. But as we get closer to our interview, which is happening at 9:40, we do have to go over some quick announcements before next class. And that I will go ahead and pass over to Avid.
Okay, yeah, so that's awesome that you guys have made your very own logistic regression model. You guys have made your own diabetes detector, which is really cool. That's really interesting. Has really good real world applications. And then just some quick announcements before we jump into our interview. Um, Today's class was about logistic regression, and then next week, next Saturday is going to be our third class, September 20th, same time from 8 to 10 a.m. PST. And then like always, these slides, the notebook, the session recording, and the assignment, they're all going to be posted on Google Classroom for you to look back at any time. We saw a lot of you guys had already submitted the assignment from last week, which is really good. And just like keep doing all of like that, staying consistent with all of your guys' work, as long as everything is posted like by the end of like the session. And then make sure you guys keep consistently checking your email and Google Classroom to stay updated. Be sure to follow our Instagram and TikTok to like see all of our content and everything. And we touched upon this last time too. And if you're looking for any real like impactful officer roles or staff roles as part of our international organization, if you want to gain service hours, we have so many opportunities awaiting. We're planning on getting like some forms out by like the end of next week for you guys to start applying for these. They're really amazing opportunities and they're like really fun for you guys to like join more into our community and we're really excited. And like always, if you guys have any questions or anything, feel free to ask us. Don't be afraid. And yeah, if anyone else is having like any errors with their code or anything, let us know. We still have a little bit of time, so we can go over that.
Yeah. These opportunities I really encourage you guys to get involved in. Like for example, we're gonna be opening our own science journal or AI journal where you guys can publish your own articles on our website on those big blogging websites,
And
and
you're
you
gonna
guys
gain
get
service hours.
yeah, you guys get service hours for that. Isn't that pretty cool? And you guys can call yourself, an author of a technology journal. Like, sounds pretty cool. And on top of that, you guys get to be part of our team. And we are a really big international organization already. We have around 17 countries and people, even though not everyone is able to join our classes, everyone is watching our classes and taking part of it asynchronously from their own time zones as well. So I really appreciate you guys coming from your guys' time zones, but unfortunately it's not feasible for everyone, so everyone's not always able to join. But yeah, we're super grateful, you guys. We have a lot of leadership also coming up, looking for people to manage our social media, do public relations, really. Other roles are also coming, so just stay tuned. We highly encourage you guys to apply, and I think it'll be a great experience. We would really love to work with all of you. So our interview should start in 2-ish minutes. So as soon as our interviewee gets here, we'll stop sharing. Are you guys excited for the interview? I think it's gonna be fun. We'll give him a little bit of time to join, but he should be here really soon. Okay, guys, he's here. Hi, Amar. How are you doing today?
I'm good. How are you?
I'm doing great. So, hi everyone. This is Amar. This is who we are going to be interviewing today. We're super excited. He's a super talented individual, and we just can't wait to jump into the interview.
Yeah,
Ready,
thank
Amin?
you so much for joining us today. We're really grateful to have you here with us. If you would just like to start off, like just telling us about yourself a little bit.
Yes, absolutely. Just give me 1 second. I'll be right back.
Yeah, of
One second.
course.
Okay, sorry about that. Yes, I'm ready now. All right, so you said a little bit about myself. Absolutely. My name is Amar, of course. I'm a junior in high school. I go to Valley Christian, and I've been interested in software for my entire life. Ever since I was in fourth grade, I've been interested in designing products and tools that have helped people. And I have two main studies of interest, and that's neuromorphic computing and edtech, which is where I do most of my work. I currently lead the HCI or Human Computer Interface Division, the research division at Princeton University, and I started my EdTech journey with a product called Stellar. I'm not sure if you've heard of it, but it's an AI-powered interactive tool that's an alternative to Khan Academy. We've impacted over 8 to 9,000 students, and we're still growing at a steady pace. I'm also building some other companies in EdTech right now and working with some people in India and China. And on the side, I'm a concert jazz pianist and teacher. I perform for local venues across the Bay Area, and we've been featured in NPR. So, also recently, I've started an open mic where we go to different venues across the Bay Area and we talk about different political or socioeconomic issues. And we have a variety of people come from there and speakers. So, yeah, it's a little bit about myself.
That sounds super cool, Amar. You mentioned that you are head of neuromorphic computing at Princeton or one of the divisions of it. Could you tell us more about your research experience and what you're doing over there?
Absolutely, yeah. So before I actually came to Princeton, I did a lot of independent research, and that stemmed from my interest in biology, believe it or not. I did some gut microbiome and thyroid hormone correlation research on how it affects Alzheimer's disease, which is a very emerging field, and that's still being published right now. It's still in the process, spent about 6, 7 months doing that. Then I moved on to Princeton, which is my current position. So a little bit about the Princeton project, very cool project, still being done today. The idea behind it is that you can imagine an image within your mind, and the goal is to reconstruct the image with the power of AI. So, using the facilities at Princeton and the variety of fMRI available machines and data sets on the web, we created this AI neural decoding pipeline where people could enter an fMRI machine, simply think of any image they wanted to. We can take those brain signals and plug it into our AI model that we trained, and then decode that into an image. Obviously, an oversimplification, but that's how I initially joined the project. And a lot of people and undergraduates, even PhD professors, were interested. I helped optimize the fMRI decoding pipeline. So that's the speed of taking your neural signals to constructing it to an image. Improving that was my goal. There's a lot of math involved. If you know what a GLM signal was, I added GLM signals to the pipeline to make it more practical, and we've seen massive success. We're applying to research competitions across the globe. We've won a few, and we're also constantly exploring the impact. This this kind of research is not just for like theoretical or whatever. This is actually being implemented in some nursery homes today because a lot of paralyzed people, they're not able to move or talk about the things that they want to get, like if they want a water bottle or something. So we're using this pipeline so that we can have a scanner that simply imagines or captures what they're imagining, and we can get them what they want. And we're still exploring the use cases.
That is so interesting and that's like so impressive. And like you're doing all these things. Like how are you like on a personal level? How are you like been balancing school, like your startups, research, and music? How have you been balancing everything all at once?
Yeah, absolutely. Good question. So, when it comes to doing all of these things, you need to find enjoyment in what you do. The more you think about what you're doing and be like, hey, I need more relaxation. I need to go do this to bring myself back or like whatever, the more you're going to be stalling your own growth. For example, I'm doing like school, like you mentioned, school, startups, research, and music. Music for me is one of my relaxation factors. People treat music like, oh, I need to go for a competition and compete against other students. But no, you can use that, leverage that for your relaxation times to recharge. The second big thing is when you're building a company or a startup, don't waste your time. What a lot of people fall into the trap of doing is, hey, I'm building a startup and I want to feel cool. So I'm going to create meetings. I'm going to schedule all of these things that don't need to be done just to feel like I'm busy. And I feel like this is something that as a society we haven't realized, but the term busyness is very dangerous. Because what happens is high schoolers like us, we want to feel like, hey, we're doing busy things. But busy does not mean it's good. Busy does not mean you're making an impact. Busy does not mean your product is good. So I would rather you do things that are actually meaningful. Schedule a call with someone if you actually need it and focus on what really matters to you. If your goal is to do competitions in music, pursue that first. If your goal is to do a business challenge, pursue those things first. This is all about your priority. Just don't do things unnecessarily. You have to understand your time. Also, I would say to utilize these existing techniques because this is many people have thought about this in the past on how to optimize your time. If you've heard of the Eisenhower matrix or the Pomodoro technique, these are all effective ways of managing your time to get things done very effectively within a certain set time frame. Also, for high schoolers who are getting to the higher course rigor, really try to optimize your homework. People really slack off and do that. But when you're taking 5, 6 APs, that can really stack up, and you're going to eventually, in the beginning of the year, you're going to say, I'm making an AI-powered startup, and then you're not going to get to do anything because you have so much course load. It's all about your discipline and your consistency. If you want something bad enough, you can do it.
That's insanely good advice, and I think that's really important considering the high amount of workload that many kids are taking on these days, especially like in this day and age, everyone's rushing to do this, and that. And I think it's really important that people learn how to manage their time, and those were some really good tips. So, given your experience, what are some tips that you would give to students looking to start their own projects, or whatever it may be, research, startups, etc.? Any tips do you have for them?
Good question. Now, believe it or not, ironically, I'm going to say this. Now is your time to fail. You have a lot of time to fail, and that should kind of be what you're aiming for. Try to do something. Do not wait too long. This is one of the biggest traps once again. A lot of people will be like, I'm in eighth grade, I'm a freshman in high school, and I have so much time to create my startup or a company, and I know it's going to be successful, so I'll do it a little bit later. What happens is when you get to your sophomore or junior year and you begin creating that one product, that golden product idea, which you're like, everyone's going to use this, you create it, you launch it, you have your go-to-market strategy, you have sales calls, you pitch it, you give VC funding for like, I don't know, $1,000 and then you launch it, no one uses it. And you're like, oh, shoot, I didn't learn how to actually go to market. I'm just talking a lot of buzzwords because I think I'm cool. So, what you have to do is when you're in eighth grade or freshman or early on, it doesn't necessarily have to be correlated to your grade. But if you have an idea, execute on it. There's little time. If people think they have a lot of time, but once you fail, every single failure is a step for you to learn from. And that sounds very cliche, but it's true because every time that your startup is not working, there's a reason it didn't work, and there's something you could have done to make it actually work. Also, second big thing is you don't have to reinvent the wheel with your product. I'm giving advice to you on how to create your product and launch it successfully. People often try to reinvent existing tools. Like, for example, if you see Cursor, like this, it's an AI coding platform to really help code and do vibe coding. People will be like, I'm gonna make the next cursor and I'm just gonna edit it a little bit and I want to redesign this completely and do that. You don't have to reinvent something that's already been done. You can enhance it for sure, but you don't have to try to take the approach that someone did that like make the next big Google, make the next big Amazon, all of that. You don't have to do that. So think carefully. Leverage existing tools and don't make your life hard, if that makes sense.
And that's all really good advice. And like when it came to creating your own startups too, could you tell us more about like Cotton and like some of the other things that you've been involved in?
Yeah, definitely. So Cotton, if you don't know, is an AI-powered digital wardrobe app. It helps people digitize their closets, digitize their clothes, and generate outfits with the power of AI. Recently, we launched one of our most impactful features that many users have been liking. It's their digital try-on for outfits. So if you upload a photo of yourself and then an outfit you want to wear, with the power of AI, it'll show you wearing it in real time. We've seen massive success. Initially, we started out, I mean, I think I launched this product in like mid-August and we've seen growth of 50, 60 users within the couple 2 weeks, which is great. But it's just successive progress. So right now, I'll share this openly, but we're at like I think 190 users. We have a decent amount of paying customers, and they're covering the costs for all of that. And it's been like a continual learning. It's like a progress of learning. I've learned that many people don't value some features over others. For example, people are like, the try-on feature is great, but it might cost too much. So I had to lower the cost and adjust things right there. And yeah, we have many future plans to make this like the biggest social media for fashion and get influencers on there, personas. Let's say you have a set of clothes and there's a certain influencer you want to look like. You can select a persona and then it'll take the clothes within your wardrobe and make you look like the person. So many features there. Regarding other startups that I'm working on, I'm working on about five more. But starting with them, well, one of them is an AI and agentic orchestration network, which was in the flyer for this meeting actually. But if you've heard of LaneGraph, or LaneGraph is an orchestration tool to take many AI agents and make them context aware, meaning you link them together and you can do multiple functions all at once. There are some gaps within that technology today, like context limits, your model progression, different models you can use. You can't, there's not much flexibility there, even though it's a very powerful tool. So I'm developing something called Null Zero. That's the name of my product, which is an orchestration network to do that, and it has MCP built in, or Model Context Protocol, more AI and technical stuff, but yeah. And secondly, another product I'm building is just a B2C. My first one was a B2B. The second one is Piver. It's called an AI shopping assistant. So the idea is there's no really AI that can help you and is specialized in shopping today. If I search up a product, tools like Perplexity or ChatGPT can try doing things like that, but they don't have built-in filtering mechanisms or they don't understand how I buy and if I want to conserve, if I have a budget. AI is not too good at that right now. So we're bringing the power of AI to shopping. Thirdly, I'm also working on some ed tech products. Taking my knowledge I learned from Princeton of neuromorphic computing and applying it to ed tech to really help personalized learning.
Wow. See, I think you're really highlighting the importance of it being adaptive. I think I really liked your example of, you're noticing that some users don't like certain features, some users really like certain features, but they think it's too expensive, so you're lowering the price. I think that shows how adaptive you have to be in like this constantly growing and changing environment. So I see that you have a lot of startups, a lot of really cool experiences. So one of the biggest questions I have for you is how do you identify these new opportunities or new gaps within all of these like industries?
Absolutely. So there are a variety of different facets you can look for problems. And what you're trying to look for is a problem and a solution. Is that all though? No. There's a third piece. I would have this like the open mic, but like the third component is you actually care about the product. Because many startups fail because the founders don't care about what they're actually building. They just want the money or they just want the fame or they just want it for college apps. So, number one thing, the first step is always the problem. You have to identify the problem, which is arguably the hardest part. You can look within your own life to see things that are troubling you on a daily basis. If you're going to school, what are things that are hard for you to do? What can you not do already? What tool doesn't exist? You can ask your parents, you can go online. And this is something people look over, but these existing platforms like Reddit and Quora and even more, people post things that they're really angry about that, hey, this tool is not meeting my expectations or it's just there's something lacking there. So you can go to these places, find ideas, and get one you actually care about. Then you have to come to the brainstorming solution. I recently attended a design school workshop at Stanford where they talked about the brainstorming, the problem identification, and the solution. And one of the biggest things they said is when creating a solution, don't stop. That's the whole brainstorming process. Sounds cliche, but I'll give you an example. For example, let's say Pivot, the shopping assistant that I'm creating. The problem we identified was that people today have no easy way to shop within budget or personalized manner using the power of AI. And the solution we came up with is to have an AI shopping assistant that is trained on a bunch of these different data sets of items across the web. Now, some people could just stop there and be like, that's a great product idea. But you need to develop this yes and. I'm not sure if any of you have heard of it, but once you have an idea, you have to say yes and then add to it. It's a very cool mechanism for coming up with great solutions. So you don't want to stop for like, I don't know, good solid 10 minutes. Keep going, have a massive conglomerate of different ideas. Once you have that, then you can go back and eliminate the bad ideas. So get your ideas out, eliminate, and make sure you actually care about it, and then you can create a good product.
That's really interesting. And like you were discussing earlier too, you were saying like this is like the prime time to like fail and stuff like that. And you were discussing like your adaptability when it comes to your startups. Are there any like other challenges that you had faced when like working with your startups and like how did you overcome those?
Definitely. Good question. I think this is pretty unanimous to all founders at a young age. It comes with credibility. No one trusts you because you're young. And that is something that even I'm facing today. Like when I talk to people who are high profile or they have a lot of money, they're VC firms and all, no one takes me seriously because they're like, okay, this is just a jokester here. They don't have anything. Number one thing you have to do is establish trust. You have to get on their good side. What's in it for them? Why do you care about them? Literally, if you want to get on someone's good side, go to a successful person and say, I want to be like you. That is the key point. You have to make them feel that they're in a position above you and be like, I'm trying to get there because that's the main thing. If you're a young founder, you have to be very humble. If you're arrogant in the slightest, no one will take you seriously. Um, and once again, with every failure you have, even if a VC firm is like, no, you're not going to get funding, it's a terrible idea. Take that and learn from that. Why do they think it's not a good idea? Don't just stop there. Many people are being just be like, hey, it's this is a terrible idea. I'm not going to pursue it. And that's why they can't get anywhere. And the third thing I would say, this is crucial. Don't be afraid to get help. Many young founders who are arrogant, they'll be like, I can build this product my entire by it all myself. I don't need any help from anyone. That means you're going to be building the product, you're going to be doing sales, you're going to be marketing, you're doing UGC content creation, you're going to be doing all of that simultaneously. No. The more people you have, the easier things are to do. People constantly are like, I'm not going to retain 100% of my company because they watch Shark Tank. They know what equity is. But the point is, your product's not going to go anywhere if you don't have enough help. Help is actually like a requirement for a product to go big. I fell into this trap as well. When I initially started this product for Valley Christian called VC Assist, I kept being like, I don't need any help. I don't need anyone to help me work on it. But then I realized, wait, if I get my friend on this, I have to do half the development. I don't need to do as much work. And then we saw more growth. 1,400, 1,500 students began using it, and it was massive success. But yeah, those are the three big things.
That's awesome advice. And I think that's a big thing people struggle with because I think people always have this ego that tells them that, oh, you're capable of doing this yourself and you don't want to give anyone else credit. But I think you really highlight the importance of sharing and, splitting the work. I think that's offloading is a big thing. We have one last question for you before we open it up to the audience. And our final question is kind of like a hot take question. Do you think AI is going to replace more jobs than it creates, or is it the other way around?
Interesting. Okay. Good question. Do you think AI will replace more jobs than it creates or the other way around? Any sector or just in general?
No, just in general, anything.
That's very difficult. Um,
However you
I
want
would
to answer
say,
it.
yeah, I would say it would probably replace more jobs than it creates, but later down the road, there's going to be more jobs being created. So in the short term, it's going to replace. Because if you look at specifically the tech industry, the most massive booming industry in the modern day, a lot of the entry level positions they're being taken by AI. So the people with bachelors in CS or CE, they're being replaced by AI because AI can do what they're doing, if not better than them. So you have to have a good amount of experience to get into the field. What I feel like is going to happen is it's going to get into the creation of AI and the development of AI itself. So there's going to be more AI researchers. Like take for example Meta. Meta traded Jiahi Yu for $100 million from OpenAI to Meta, which is insane. So there's a lot of value for these researchers going back and forth. If you specialize in some concentration that AI is not good at, that will be very impactful. And that's what I think will create the jobs later on, which is why a lot of people are getting into CE in college right now. They're going from CS to CE, which is computer engineering, more hardware aspect, because AI can't do the hardware yet, which is why there's more demand. So, to answer your question, I definitely think short term it's going to replace quite a few jobs in a lot of sectors. But in the future, there's going to be more jobs to really be above the AI and teach it more, you know?
That's pretty cool. I never thought about the entire like CS to C thing. I guess you're right, the fact that, AI is not being really implemented in hardware as much quite yet. I think there is a growing rise with Nvidia and all that booming. Um,
Definitely.
so now if the audience, I know it's already 10, but if anyone else has any questions for Amar before we close the interview, this is your chance to speak up and ask whatever questions you want. Yeah, great. Gabriel, feel free to unmute. Okay, Gabriel, you could go first.
Yeah. So I've been hearing about your journey with all these AI startups and your like that progression, but I'm curious, like what sort of resources did you use to initially learn AI and then eventually expand into all these startups?
Specifically technically, or do you mean the people?
Technically, and then people too, if you'd like to share about that.
Definitely. Okay. Learning AI. CS. I started CS at a very young age. I started in, I think, fourth grade, which is when I began learning Python and C++ and all these different toolings. And then I decided, wait a second, I want to build impactful products. So I went into web dev. I learned React Native. I did all these things, created mobile apps. When it came to AI, though, that was actually the biggest struggle point for me because I could see that many people are struggling to gain a knowledge on this field. First, understand what you're trying to do. Like, if your goal is to create a product, think about the technology you're using, and I would say understand that. Even if it's not related to the programming aspect. It sounds very strange, but let's say like I'm building this shopping assistant, right? I'm using ChatGPT. What really is an API? Like that's just the CS fundamentals. But when I'm using certain features from AI, how do those work? So I was very curious about that. Also, you should be up to date on a lot of newsletters and stuff like this because I'm subscribed to like six different AI newsletters. They update me on a daily basis on the new modern tech for AI, like Claude Code released this or Cursor released that, all of that. So you be very up to date on all of these different toolings. It also, there's a ton of these platforms like roadmap.sh. I strongly recommend that one. If you're learning AI, it literally gives you a step-by-step process on how to go from zero knowledge in CS to a masterful AI coder. Highly recommend roadmap.sh. You can practically learn anything. It gives you the process there. Your second part of your question about people, networking, very good question. You have to insert yourself in today's society. There is such a growth about the amount of people who want to get into AI and tech. It's actually ridiculous. So what I do is every 2 or 3 weeks, I go to these AI conferences held in San Francisco, and I just attend these. I go with a friend, or I either go alone, I go with my mom, and I meet new people there. And I just get their contact. And it's not just like, hi, can I get your contact? You actually make a connection, being like, hey, I'm building this, you're building this. Maybe you can collaborate, maybe you can have a meeting, we can discuss certain ideas going back and forth. Meet new people, insert yourself like there's no other way around it. And if people don't allow you in, go to a different place to insert yourself. That's how I recommend meeting people. I think we got a question in the chat.
Nah, I think that was just someone letting us know that they have to leave.
Oh no,
I
no,
don't
I
know if
got a
that's a
private
question.
message.
Oh,
Oh
private.
wait,
Okay.
yeah, yeah, yeah. Let's see here. Ati, I think Ati Karthik. Hi, I am writing a research paper on AI. What skills would you recommend students build if they want to do AI research? And how did you contact professors to do research? And what strategies you use to get around 200K users? Hmm. If they want to do AI research, what skills should they build? You need to read a lot of research if you're doing AI research. I hate to break it to you, but the amount of AI research available right now is ludicrous because everyone wants to do AI research. That's the number one hot topic. And these research papers, I don't mean they're coming out like monthly. They're not coming out weekly. They're coming out daily. I read one every like 1 or 2 days, like in my spare time when I get up in the morning. So be very up to date. I don't know specifically what you're researching. If it's optimizations of AI, there's so much out there already. So be very careful before you proceed to make sure that that research is actually meaningful and worthwhile. And your second part of your question was how do you contact professors to do research? Cold emailing was very popular for like the last few years. Many people began doing it, and professors began having the sense that like we're not going to take a high schooler on. This is too much work. Try to leverage your network. I know it seems very daunting to ask your mom or your dad, being like, "Hey, do you have any connections to AI research people or professors?" They'll probably say no. But if your mom knows someone who works at NVIDIA, maybe they do know someone who has some research experience. Also, utilize LinkedIn. I'm a LinkedIn nerd. It's like pretty cool. I meet a lot of new people there. I get like a lot of messages every day, and you chat about a variety of topics. But there are some pretty impactful people on LinkedIn, and if they see your profile is strong and it's worthwhile, then they can help you get some things like research. Also, talk to people who have the research. So if there's someone working at Princeton, if there's someone doing research at Maryland, all these different schools, contact that person and see if they can get you connections to the research department, and review your work to see if you're worthwhile. And your third part of your question was, what strategies did you use to get around 200K users? Specifically, I built an edtech product that is, I don't think anyone has really entered the space. But if you know publishers like McGraw-Hill and other ones, I built an AI product to replace the textbook, if that makes sense. So for all of these humanities and engineering classes, there's these textbooks that are not AI powered, and students can't ask questions live, like right inside of the textbook. So we designed a platform that recreates the textbook. It doesn't use existing ones. AI generates a textbook and a platform which you can create quizzes for and tests for. So students from universities can sign up and take these exams, and it makes it really easier on the teacher side. And then we contacted UCs. We set up sales calls. We got some a lot of interest. And then some teachers are ready to just implement it day one. So this product is being used widely. We have it implemented at some IVs. We're working on Princeton and Stanford and even MIT. And yeah, so 200K users have a go-to-market strategy. It depends on your product. It's very vague to answer without a product, but have your strategy and execute and get feedback, fail, and then repeat. Okay, I think we have a hand raised. Anjali Balne. Yes, what's your question?
Hi, my name is Anjali Balne, and I'm an eighth grader at Iron Junior High in Conroe, Texas. I'm super excited to be here and get the chance to speak with you today. So my friend Bhavna, who's also in the Zoom call and doing UTX AI with me, has prepared two questions with me today, and if you would be willing to answer, that would be amazing. Okay,
Absolutely.
so my number one question is we're currently working on a science fair project for a competition called the Science and Engineering Fair of Houston. It's a multi-level competition and we're really aiming to advance the state this year. And since you've done research and entrepreneurship, if you have any advice on how students like us can stand out with their projects or maybe even connect with mentors, labs, organizations that could support young researchers.
Mhm. So are you doing the research with an organization or independently right now?
It's an independent research, but you have to present to it's kind of like science or like regular science fair.
Got it. And is it AI or is it a different field?
We're currently doing biomedical engineering and we've brainstormed a couple of ideas like a detection system for possibly diseases such as tuberculosis and cancer leukemia, but we're open to different ideas.
Yeah, good. Actually, there are a ton of Discord communities that I'm a part of for biology and this exact stuff. They're specialized in research, and there's a tons of research papers and articles that these guys post around like a variety of these topics. Like for me, I did thyroid hormone disease in correlation to Alzheimer's. It's being published right now. But get in these communities, talk to the people there who created these articles because they're very knowledgeable. Some of them are ISEF Regeneron winners. They're crazy people. As I said, LinkedIn. there's this one guy, he keeps appearing on my For You page. He's like Ishan Jain. He's like YRI. He's like the Research Institute. There's all these different research programs and accelerators that help you get sped up and meet these kind of people to get in contact for this research paper. Obviously, the specifics of your paper matter, so I can't give like very personalized feedback, but try entering those communities, meeting those people, and setting an actual execution deadline. If you don't do anything, nothing's gonna happen, of course. Hope that
Okay,
answers your
yeah,
question.
thank you. hmm my second question is that Bhavana and I also initiated and registered a team for our school under this competition called Future City. It's a regional STEM competition where middle school students imagine, design, and build a model of a city that's at least 100 years into the future. And if we place, we can possibly advance to the national competitions. And teams work together to solve real-world problems using engineering, creative innovation, technology, and every year there is a different theme. And this year is to eliminate food waste in the future from the farm all the way to our dining table. And to form an official team, we need to connect with a mentor who is an engineer, technician, architect, urban planner, etc. So we were hoping if you knew any sort of reliable and legitimate sources on where we could get potential technology, resource tips, and any connections for possible mentors.
Yeah, I think you cut off for me halfway, but you said something about food bank. Could you repeat that?
Oh, yeah. So the competition has a different theme for every year. So this year is basically you have to create a physical city, like it's like a cardboard box. Um, and you
Mhm.
have to create it where it's basically a city in the future, right? So you
Mhm.
have to include all the utilities, like where your residents live, transportation, um, just like how a regular city today looks like, but in the future. And the challenge that you have to overcome is to eliminate food waste from farming all the way, the process from the farm all the way to our dining table.
Oh, got it. Okay. There's a good amount of high schoolers working on something very similar. Yeah, like I even have a friend who's working on this project to I think it's about like understanding one city better. So they create these 3D printed cutouts of a city and like then they say how can we solve societal issues based on this model and what are some geographic concerns. It's a little bit different than what you're working on, of course, but
Mhm.
there are these different communities like that. So try to meet these people. I'm not sure how many people are working on your project right now, but if you is it just you or is it two?
Um, I'm working with Bhavna and another friend.
Okay, got it. Yeah. Once you have a solid team, you're good to go. But mentor-wise, this sounds like a very niche field that's hard to get a mentor for. Um,
Mhm.
but you should probably aim for something more for someone who has a lot of experience in like societal issues or agriculture, from what I'm hearing. That seems like they can help you the most. Or you should get a research mentor. Research mentors nowadays for things like that are a lot harder to get. But it depends on your goal. Is your goal to become the state champion or is it to actually make an impact with it?
So in my region, we first go to the regional competition, which is like
I see.
since Texas is so big, they split Houston and the rest of Texas. So we
Mhm.
have to, if we place in the regional Houston competition, we can directly advance to nationals. So our goal is nationals.
Got it. Yeah. Yeah. Just make sure you really care about what you're doing. Biggest
Okay,
thing.
yeah.
Yeah, yeah. That would be my number one advice if you forget everything else. Care about what you're doing.
All right. Thank you so much. Your insights really mean a lot.
Thank you.
Is there anyone else who has any more questions for Alar?
Oh, I got a chat message.
Yeah.
Um, I know we're like over time, but if you can answer one of my questions below, I'd really appreciate it. Number one, in your experience, how can AI help bridge accessibility gaps for users with diverse needs beyond traditional assistive tech? Two, you were talking about this earlier about AI taking jobs. Would you say that it would also be something like AI won't take over an engineer's job? An engineer using AI will? Have you used AI automation within your startups? All great questions. Let's start with number one. Wait, by the way, do we have like a time limit?
No, you could keep going. There's a
Okay,
time.
yeah, yeah, I'll be mindful of time, but
It's okay. Yeah, don't worry.
Okay, accessibility gaps. That's actually my number one field right now. As I said, after my research at Princeton, we're actually implementing this in nursery homes for accessibility. So I think accessibility, more of it lies within the hardware, believe it or not, because there's many difficult things to do with only software. People have developed these different products to help capture like memory or knowledge bases for people, and that can help with their accessibility or whatever. But don't try a software route for that. Understand your hardware, and if you're really into that, I recommend neuromorphic computing, which is where you study spiking neural networks, SNNs, modeling your memory behavior, and that would be your first step through that. And I feel like that space has not been explored at all. So that's definitely a really good space to get into. But that's only if you have some experience with hardware. Otherwise, it's very difficult to do. Let's see, beyond traditional assistive tech. Yeah. If you're looking for a specific thought about this, you should probably look into personal companionship. A lot of companies have been creating these therapeutic AIs that are like physical, so it might be a little strange, but these elderly people, they can talk to these AIs that are physically there, so they think they're talking to a person. Interesting. Number two, AI taking jobs. You said so AI won't take over an engineer's job. An engineer using AI will. The issue is entry level. Entry level means you're entering. You don't have enough experience right now. So engineers who know how to use AI effectively and are in a senior position, they can cover for the mid or entry level positions already. So your goal, if you're trying to enter the tech force at least, is to get to the top. And you're right. It's not that AI will take over an engineer's job. An engineer using AI is going to take over. That's exactly right. I agree with you. But if your goal is tech force, obviously get to that end goal. So that might mean you have to take a master's degree in a concentration of AI so that you're specialized in it so you can go not you can jump that entry field position. But if you really want to get into the tech force, utilize connections. Like that's the number one thing. Get an internship from your uncle. Everyone does it. Then go to a different company and apply. There's a new trend called it's called spraying, I think. But you go to LinkedIn or these other apps, you apply to like 150, 200 jobs. You usually get maybe two or three job offers. And you could go from there. You can go through the not job offers, I mean interviews. You can go through there and you can try to get a job offer. So that's a strategy as well. And thirdly, have you used AI automation within your startups? Yes, I use automation literally every day. Favorite tool, NAN, shout out. I'll paste a link. I actually like it that much. It's called NAN. I recommend everyone try it. It's like this automation tool, and you can automate anything in the world. There's also make.com if you don't want to pay, and a variety more. Yeah. Don't try to waste your time doing unnecessary tasks. Hope that answered your question.
We have one in the main chat if you see it from Parihad.
Oh, got it. Okay.
Yeah.
Once you have a product, how does one obtain users from zero? How would you get all the people, especially if you need to pay for services like an AI API? Good question. Develop a go-to-market strategy. That's exactly what a go-to-market strategy is. How are you going to get into your market? There's a variety of mechanisms of doing this, but it depends on the sector you're present in. For example, in edtech, which is one of my biggest spaces, you need to understand the existing products and their go-to-market strategy. So it varies per product. For example, Stellar, when we were advertising it, we realized that high schoolers, they look at a lot of reels on Instagram and TikTok, and they're struggling on a variety of concepts. So what if we publish these videos being like, hey, do you need help on AP Physics? Try out this tool. And that was closer to the AP exam date because everyone wants help on their AP exam. So you have to be strategic about how you get your customers. Yeah, even Cotton is a good example. There's this other company called Wearing, which has about 6 to 7 million users. And they developed an amazing product and they had a great go-to-market strategy. They partnered with different clothing companies within the UK and they advertised the product and it was like a win-win for both. So analyze your competitors. That's how you obtain your users. Develop content so that you can attract your users. And content is very vague. It can be UGC or user-generated content, Instagram, TikTok. It can be LinkedIn even. Many people have been utilizing that. Um, Second part, you said, especially if you need to pay for services. When you're building a company, there is an upfront cost to it. There's an initial investment you have to make. When I built Cotton, before I made revenue at all, I had to pay about I think $350 upfront, which sure it isn't a lot of money, but there has to be some sacrifice made to put that foot forward. Because if you don't have a paying customer, you're paying the API out of pocket. AIs can get expensive too. So if you're working with an expensive AI like an image generator, which I was, you want to be mindful about your user limits so that if they hit 50 or 100, then we cut it off. Hope that answers your question. Oh, Hannah, do you know any trusted AI automation tools? Yes, definitely. The one I mentioned, NAN. Oh, I pasted it in the private chat. Let me paste it here. Yes, NAN, great AI automation tool. I don't think it's free, but there is a free trial. Okay, unfortunate. Yeah, but this one is free. It's a little less powerful, but I strongly recommend that. It's make.com. You can create some pretty powerful automations. But if you're looking at like what automations can you create, if you have a Gmail cycle, for example, this is something I did like earlier today, believe it or not. If I have a ton of people messaging me for support, there can be like this Gmail cycle which has a knowledge base of my existing product and frequently asked questions. So if they ask a question, it auto replies with the answer. Stuff like that. Alia, what did you do to become more disciplined, consistent, and how do you determine what sacrifices are appropriate to make? Excellent question. Disciplined. That comes from just trial and error for me. Like I didn't think day one, I'm gonna be more disciplined and ready, set, go. No, because I developed a bunch of products and a lot of them failed. I shared with you some of them today, but a lot of them I did not share because they're not successful. I wasted a lot of time and hundreds of hours doing that. So I began realizing that for discipline to work, I need to actually care about what I'm doing. If I don't care, nothing will happen. So the biggest trap, remember, if you don't remember anything else from today, biggest trap is that you should actually care about what you're building. If you don't, it's not going to work out. I care about Pivot. I care about my EdTech product. I care about my AI orchestration model, which is why I think it's going to go big. And yeah, and if it fails, no worries. I'm going to move on to the next product. Consistency, yeah, same thing. It develops from that cycle, and really caring about what you want to do. Because if you want something badly enough, you'll find a way to do it. And how do you determine what sacrifices are appropriate to make? That comes from experience. The first sacrifices you make are going to be the worst ones. I've wasted hundreds of dollars making dumb decisions, buying this tool that would help me, and it did nothing for me. So as you learn, as you waste more money, believe it or not, you're going to make better sacrifices. Hope that answers your question.
Okay, I think that's pretty much everyone's questions. If anyone has, this is your last chance before we end the meeting. So I'll give like 10 seconds if you have a question. All right, unless Amar has, oh, we have one.
All right. Where do you see AI heading? Very, very interesting question. Obviously vague, but AI is one of the most impactful tools to for humanity ever, obviously. But I feel like it's not just one of those things where it's like the iPhone. It's not just like another MacBook or a laptop, the introduction of that. It's like the fact that AI can model intelligence is the game-changing factor. Because that means we have a replacement for human intelligence, which is why everyone began saying AI will replace jobs. AI, everyone has said this before, but AI I feel like is going to be a tool that will be used at mass scale, but it's going to become very dangerous too because there's many worse cases that AI can be used for. And I'm kind of concerned about the ethical use cases for people with malintent or even the government. I don't know how they're going to use AI, but yeah, you should probably be very mindful about what you're doing and try to make an impact out of it, because AI will continuously improve, and make use of the tool. Yeah. Any other questions? I think that's all.
Yeah, I think that's all, especially because we're over time. But
Yeah,
thank you
definitely.
so much, Amar.
Thank
You
you
got
so
shared
much.
so much insight with all of our students, and I think they're super happy to have you. We'll have more students watching the recording as not everyone could make it today. But we really appreciate you being here, and thank you so much once again.
Thank you so much.
Absolutely. It was a pleasure speaking with all of you. Thank you guys so much.
Yeah. All right.
Yeah, yeah. Is there any further way to reach out to me? Yeah, let me paste my email. Right here. 1 second. Okay, there we go. Yeah, that's my email.
All right, and I think that concludes the end of our meeting. Thank you so much, everyone, for coming today. I hope you guys appreciated the opportunity to connect with someone super cool like Amar. And And yeah, everyone's free to leave when they're done and have a great day. Bye, everyone.
See you guys next week.
Thank you.
All right, we're gonna end the meeting for everyone. All right, see you guys. Bye.
Bye.